In this tutorial, we will be discussing part 5 of the review for the final exam. We're going to be focusing on percent composition and empirical formulas. So the difference between an empirical formula and a molecular formula is whether or not it's been reduced. For instance, a molecular formula, you do not reduce it, whereas an empirical formula is the most reduced form. So here, if you look at the empirical formula, 2 and 5, you can't reduce that any smaller. Whereas a molecular formula, 4 and 10, if we divide both of those by 2, it becomes P2O5. 10 and 22, once again, both divisible by 2 to become 5 and 11. Now, it's possible for a molecular formula to be both empirical and molecular. It all depends on the compound itself. But you'll have to remember that the empirical formula is the most reduced form, whereas the molecular formula could or could not be the most reduced form. But if you see that it can be reduced, it's automatically not empirical. So let's take a look at percent composition. Percent composition is how much of the molecule is a specific element. So you're looking at the weights. So when we're talking about percents, we're percenting by the weight, by the mass of it. And we're going to take the percentage and we're going to convert it over to the empirical formula. Because essentially what happens is we have a compound, we put it through a machine, and then the machine tells us it's this percent sulfur, for this example, and 49.95% oxygen. And from there you can figure out the ratio based on the molar masses and whatnot. So in here we have a rhyme to help us remember what to do. Percent to mass, mass to moles, divide by small, multiply till whole. So percent to mass, all we're going to do is change the percentage to grams. And then we're going to go grams to moles. And as you know, the key term for molar mass is grams, or weight. So therefore, we know we're going to look on the periodic table to figure this out. So we have 50.05 grams instead of percent now of sulfur, and we have 49.95 grams of oxygen. We're going to put those over 1 to make them into fractions. Look on the periodic table, you find sulfur is 32.066. So I'm going to put that on the bottom because that mass, that number is the grams per mole. So that means sulfur is 32.066 grams is equal to 1 mole. So since that number is with grams, that's why it's going on the bottom. And then 1 mole goes on top. I divide that out and that gives me the moles of sulfur. That comes out to be 1.564 moles of sulfur. I'm going to do the exact same thing with oxygen. If I look at oxygen, it's right here, 16.0. That means 16.0 grams is equal to 1 mole for oxygen. So grams are on top, which means I want to put grams on the bottom. 16.0 goes with grams. 1 mole will go on the top. So 49.95 divided by 16.0 comes out to be 3.123. Alright, so let's look at our rhyme again. Percent to mass, we change the percentage to grams. Mass to moles, we change it to moles by using the molar mass. Divide by small. So you look at the two numbers and you decide which one's the smallest. 1.564 is obviously the smallest, so I'm going to divide both sides by 1.564 because we're looking for the ratio. So that means sulfur is 1, and then oxygen is 3.123 divided by 1.564. That's approximately 2. It comes out to be 1.99. So that means the chemical formula here is S1O2. I don't have to write the 1 because it's given. if there's a blank. Multiply to whole, we didn't have to do that part. If this would have come out to be 2.5 rather than 2, I'd have to multiply them both by 2. I look at that by looking at the reciprocal. So 1.5 is 1/2. I would multiply that by 2 because 2 is the reciprocal of 1/2. But we didn't have to do that here. But I'm just letting you know just in case that situation comes up. Alright, so let's try another one. Now, pardon me, we figured out the empirical formula. This, the SO2, was the empirical formula of what we just calculated, of the information that was just given to us. So, from here we can figure out the molecular formula. But in order to do this, the problem has to give you the molecular weight. If they don't give you the molecular weight, you can't do this. Because once again, we're looking at ratios. So, we take the chemical formula of the empirical formula, and we have to look at the molar mass of that. So S is 32.066 from the previous one by looking at the periodic table right here. Oxygen, we have 2 of them, so 2 times 16.0. Once again, that came off the periodic table right here. And we're going to calculate out the molar mass. That comes out to be 64.066, 64.1, something like that. Alright, so from here, we have the molar mass of the empirical formula. And from here I can figure out the ratio by dividing the molecular molar mass divided by the empirical molar mass. So that comes out to be 128.1 divided by 64.066. That comes out to be approximately 2. So that means this SO2 here would then get multiplied by that 2. That 2 is right here. So that becomes S2O4 as the molecular formula. So what you do when you're looking for molecular formula, you figure out the molar mass of the empirical formula, and then you divide the weight of the molecular formula divided by the molar mass empirical formula. And then that'll give you a ratio to multiply the formula by. The last thing we're going to do in this is we're going to calculate the mass percent. So in the previous questions, we were using the mass percent. Now we're going to calculate the mass percent. So here, the first thing you want to do is figure out the molar mass. So we have Ag and Cl. We have 1 silver and 1 chlorine. If we look on the periodic table, we find that silver is 107.9, or 107.858 if you want to use the whole number. Chlorine is right here, 35.453. So we multiply that out and you add it together. And that comes out to be 143.311 grams per mole. Now, if you're looking at the mass percent, you're looking at how much silver is in this one compound, how much chlorine is in this one compound. So what you want to do is you want to look at the percentage. So you're going to take just the silver. So whatever 1 times whatever the mass is, whatever that equal to is going to be on the top, divided by the total molar mass. times 100. That comes out to be 75.3%. Now, if by chance this was a different number here besides 1, if it was like a 2 or a 3, you would still take what it equaled to. Don't take just the elemental mass. Take the entire thing that's contributing to the compound. Then we're going to do the same thing with chlorine. So we'll take the mass that chlorine contributes and divide it by 143.311 times 100. And that comes out to be 24.7%. So the mass percent of this, the silver is 75.3, the chlorine is 24.7. Make sure you answer the question being asked. It's specifically asking about silver. And that's how you do empirical formulas and mass percents.